Welcome to the Quick Start video for Unit 9 on bits, bytes, and binary. Here's what we'll cover. We'll introduce the learning goals and computer science concepts. We'll call your attention to some key preparation and additional materials. And finally, we'll summarize each lesson's main activity. Now feel free to have the materials open as you watch so you can pause at any point to look at them more closely. Now, during this unit, students will understand what bits and bytes are and how they relate to computers and the way that information is processed and stored. They'll learn to count in binary, also called base 2, and they'll translate numbers between binary and decimal, or base 10. And finally, they'll create a unique program that uses binary counting as an integral component. Now, the earliest computers used a series of mechanical switches to control the flow of electricity through their circuits, turning each one on or off to represent and store information. Now, the smallest unit of information, which represents the state of one switch, is known as a bit, which is short for binary digit, and it has only two possible values, 0 for off or 1 for on. Now, a byte is a sequence of 8 bits that are strung together to represent larger pieces of information. And you can think of each digit in a byte as representing an individual switch that's either 0 for off or 1 for on. Now, modern computers use transistors with billions of tiny switches of digital circuitry, and the information is still represented as a series of zeros and ones. Now, in coding, the zeros and ones of bits and bytes can be used to represent letters, numbers, and even different keys on a computer keyboard. And a bit can be used to hold a Boolean value where a value of 0 is false and 1 is true. Now you can reference the article and video explanations of binary systems through the links in the recommended resources area for additional support with these concepts. And these are also great resources to share with your students. Now, your preparation includes the usual steps at the unit level. For the unplugged activity in Lesson A, you'll need to create game coins in advance. Now, the additional materials are listed, as well as some simple alternatives. It could be as simple as using sticky notes, for example. Now, each pair of students is going to need a set of 6 coins in denominations of 1, 2, 4, 8, 16, and 32. And these can be as simple as a piece of cardboard or a piece of paper just with a number printed on it. There are some suggestions for creating the coins. If you're located outside the United States, you can modify the core denominations in the overview section of the activity. These aren't real denominations anyway, right? They're not real coins. But you can call them units or some other term that's familiar. Now, your Lesson B preparation includes reviewing the coding activity mod ideas, and if you're going to offer your students the option of building a transmogrifier, you'll want to be sure to have the materials available. And in addition to the usual prep in Lesson C, you're going to need some quarters, some copper tape, and some Velcro tabs. Now, remember that purchasing suggestions they're all in the course overview guide. So for Lesson A, the unplugged activity uses a vending machine concept to explore binary, how it relates to the decimal system, and how to convert numbers between the two systems. So you'll give them an overview of the decimal system and then follow the step-by-step instructions for how to alternate between distributing the prepared base 10 coins in stages, the tasks for the students, and then discussion questions. And then you'll introduce the binary system and how to translate numbers between base 10 and base 2. Now, if you're concerned about your students grasping the concepts through the activity alone, you might consider assigning some of these resources to them as prep or as a follow-up to the lesson. Now, in Lesson B, the activity is coding a microbit binary transmogrifier. So the user can press different combinations of the A and B buttons, and they'll enter a binary number, and then the microbit will convert and display the decimal equivalent. So it's really kind of like a binary calculator. So you can follow the instructions to help your students figure out the conversion pattern. There is a pattern that if they see it will help them to code this. And then you might want to coach them to write the program first in pseudocode. So write out the steps in English first. And then finally, they'll go and they'll build a program in MakeCode. Now for the project in Lesson C that has students coding and creating a binary cash register with the microbit. And so an example of one possible design is provided along with some tips. And there are also modification ideas. So here's a simple example using the quarters and the copper tape to either complete the circuit or break the circuit. And so it'll be on or off. And there's also an additional project to build a binary watch. And you can offer that to any students that finish the main project faster than others do. And that's it. Have fun with this interesting unit about bits, bytes, and binary systems.